Hi everyone, my name is Rodrigo Tomas. I'm a Senior Applications Engineer at Bosch Rexroth US, and today I'll show you how to do a basic motion control system using Bosch Rexroth MLC. And MLC stands for Motion Logic Control Based, along with the servo drive IndraDrive platform that we have already talked about in previous videos. Alright, so let's go straight to Google. Let's download IndraWorks, and then we'll start playing with IndraWorks and its features, and let's create like a very nice motion control system together. Alright, so if we search for Bosch Rexroth IndraWorks download, if we are lucky enough, IndraWorks should be the very first link that you see here, and then you can go to our website. Alright, so once the website is open, you will look for the downloads tab down here, and there are many modules and options that you can download, but the one we are looking for today is called IndraWorks ML version 14, which is the latest one. So this is the one we want to download. All right, it's a big package. I have already installed it on my computer, and just take your time, download it, install it, and once you are done, you should see IndraWorks, and it should look similar to this. If you are not yet familiar with it, there is another video in my channel that talks specifically about IndraWorks, so I would suggest you to take a look at that if you haven't yet. So once IndraWorks is available, we can create a new project, whether by clicking on this icon here on the top left, or right clicking on this blank area and saying new project. And then we need to select like a destination for this project and give it a name. I will call it MLC Basics Tutorial, and then I'll hit enter. This version here, I would strongly suggest you to keep the latest one. All right, unless you need to communicate with an older version of firmware or something like this, but if you're creating a brand new project, just stick with the latest one. All right, so let's hit OK. Our project has been created, as you can see. We then need to add our motion controller, and we can do that whether by coming to this library on the right side and drag and drop the controller to the project, or instead you can right click and say add, and then look for MLC, which is the platform we want to add. And there are different controllers, which is the hardware. The one I'm using is called XM4. In your case, you may be using XM21, XM22, and that would be this XM2 here, or even L75, L25, 45, or 65, and you see it under this list. So whatever you are using, you just select on this list. I will go with XM4, and in my case, I'm using XM42 controller. All right, so we start. You can give a name or just use the default name that has been selected, and let's hit next. The next step is to select the firmware you want to use. Again, I would strongly suggest you to stay with the latest version, so no need to change in this case. So I have MLC version 14 and release 22 for the firmware. The default Ethernet configuration that comes on the MLC is this number that you see here, 192.168.1.1. I can click, if of course if your computer is properly connected and has a fixed IP already configured for this specific range, and if your controller is properly connected and on, of course, and then you will come and execute So if the computer can communicate with the controller will respond with some information that you can see. In my case, the firmware has already been installed on the controller, but if this is a brand new controller out of the box, you may need to install a new firmware to it, and I will show you how to do that, all right, in the next few steps. So in my case, again, it's already installed here. I'll hit next. There are a few options that we can select here. I will disable this one. The secure online mode is just like a few warnings that are displayed every time you want to load a new PLC project. In my case, just to make it easier, and I'll just remove it, but for a real machine you may need to leave it. So it's up to you. It's not required, but you can leave that. I'll hit next. In this wizard, we need to select the licenses that we have purchased for the MLC controller. All of them are configurable, and in this case I need motion. I don't need the technology for today's training. I don't need robot, I don't need hydraulics, I don't need OPC UA for this training, but you may need it to communicate with your HMI. Open Core Interface is a set of APIs that allow you to communicate with this motion controller by using standard language such as Java, JavaScript, C++, C#, and many others. We are not going to cover that today as well, so just keep that unchecked. This controller also supports EtherCAT master, so it can be an EtherCAT master controller. This is not the case for us, so just leave it. And I will hit next. And here you will select the communication of the controller. Depending on the controller that you have, you may have less options here. So as I have like the most powerful controller, which is XM42, I have a lot of options to select here. You may just see maybe one or maybe two of these menus. So it may look a little different depending on the controller you are using. But in this case, we can configure the controller that I have can be configured to be a Profinet controller or device, can be configured as an Ethernet IP scanner and adapter. We can select the engineering part to be an Ethernet IP adapter as well. We can add additional function modules that will add additional functionalities to the controller. So I'm not going to talk about they specifically today. And what we actually want is to have like deterministic bus or deterministic field bus communication protocol that could be EtherCAT or circles. As I'm dealing with IndraDrive, I will keep circles as my master communication. All right, I'll hit finish. It should take a few seconds, and we'll see the controller showing up under this tree in a few seconds, and we are almost there. There you go. So you see there are some things we need to talk about, but before we move forward, let's talk about the firmware management that I mentioned to you. In case it's a brand new controller, or maybe you have like an older firmware installed on this controller and you want to upgrade it to the most recent one, you can click on this firmware management, and then it will communicate with the controller and tell you what is installed and show you what your IndraWorks can provide as far as firmware versions. So you can just hit download and the process will start. It's important to mention that once you start this process, it's always a good idea to make sure that the power supply is safe, because depending on the status of the firmware installation, if you kill power to the controller you may actually lose the controller and you would need to send it for maintenance. So I don't need to do it. I'll just close this wizard here, and then I will, first of all, I will switch online. So you'll see a few things, and first of all, you may see that it says partially synchronized, and means that the controller doesn't recognize what is in this project, so they are different. They don't have the same identification. But before we move forward with the motion part, I would come to these language settings, and you'll probably see German language, and we can change it to English, so we are good to go here. And next I will switch offline, and then I'll come to these circles. Let me expand this motion area so you see something happening here. I'll come to circles, right click to it, select scan bus configuration. So the circles bus has been scanned, and it shows me that there is an IndraDrive connected, physically connected. I can give it a name, so in your case it can be called X, Y, Z, Mandro, or any kind of axis name that you want to give. You can write anything here. I'll call it axis 1. Alright, and then I'll hit add device, and I will close. As you can see, I have a new axis here. I will collapse this. We won't be using this area, and you see that the axis has also been added under real axis here. Alright, the next step I will do is to show you something a little different. We just added like a physical axis or real axis. I will add as well a virtual axis, and virtual means that the axis resides in the controller. Of course you cannot physically see it, but we can use its position and velocity for synchronization features or things like that. So let me add VX1, sounds like a good name. I'll move forward, and I'll give it a number. Let me call it 10 instead. So it's gonna be my axis number 10. Virtual axis, I'll finish it. And alright, so we have real axis and the virtual axis. I will come here again and switch online. Once again, it says partially synchronized. So now that I have completed the axis, like I have included all the axes I want in my project, I can right click and say synchronize, come to download, and it will check and ask you safety questions such as, is your machine safe? Are you sure you want to overwrite whatever is on the controller? Let's say yes. It takes a few seconds. Alright, now we have the system is in P2, and P2 in other words means that the communication and also the controller are both in parameterization mode. So we can go through some configuration steps, and we actually need that. But before we continue, let me do something similar to what we did a few minutes ago. I'll go back here, language settings, and besides configuring the controller to English, I will configure the drive as well. So, and then I will write, and then I can close. That's all I need for now. And next step will be let's configure the axis. One thing that I would like to mention is that I have created recently an IndraDrive training, so I won't mention like specifics on IndraDrive configuration. If you are still not familiar with IndraDrive, I would suggest you to take a look on the video that I posted a few weeks ago. It's in my channel, it will be easy to find it. And we can click on setup, right click on axis and click on setup. You will see a wizard coming, and if it's a new drive you can just hit next. If it's a drive that you've been using for some tests and things, maybe it has like some garbage, some parameters that have been changed and you actually don't know about them, so it's always a good idea to do a load basic parameters. I don't need to do it here because my drive is brand new, so it's good to go. I'll hit next. This will be a rotary system. I will have a module of 360 for both the physical and for the virtual axis later as well. I'll hit next here. Mechanical gear, I have no gear. And my maximum travel range, I'll keep it at 3600 degrees, it's good. I have no brake. Here comes a gotcha on the MLC. Even though this actual position limit is deactivated right now, the drive will still check those two parameters and it may generate an error in case you try to change it to operation mode. So before moving forward, I will select activate. I will hit write 0 to this, write 0 to this one too, and then deactivate. So we are good to go now. And I'll hit next. So in this screen, the only thing we really need to pay attention to is our system allowed to move only positive, only negative, or can it move either way? So I'll leave it shortest distance for me. And it's important to mention that this configuration here is only meaningful for move absolute motion. All right. So hit next. This is the e-stop configuration. I don't want it. This is how we can configure parameters or some parameters. Like there is a list of parameters that I can configure from the drive to be sent to the controller for a cyclic access to those parameters. And this is a bit access, so once I select like any of those, I would need to kind of select which bit I want to watch, because this is a status word. I don't want anything from here for this demo. I'll hit next. I have the exactly same thing for control word, which means you can write to this bit. That would be like commands, for example, drive controlled homing, some like save, backup, things like that. So those are some parameters you would be able to select on this list for cyclic access. Again, I'm not selecting any of those for this demonstration, for this basic demonstration. I'll hit next. Some status message configuration, I'm not touching this as well. As I mentioned, if you have questions, please go to the IndraDrive training. I will talk in details about this. And I'll hit next. Here are some error reaction in the drive. I'll keep it the way it is. Hit next. And another one, again, a cyclic circles channel for read and write axis, but those are like a real values, double word values, while the previous one that we saw was just bit axis, all right? So the same thing, cyclic axis, that from parameters that we could configure to give controller the ability to read or write to those parameters directly. We are not touching it. I will hit finish. So the basic configuration of my physical axis is completed. I'll do the same for the virtual. So hit next. Rotary module 360. we can do the same for the limits here, 0, 0, and deactivate. And same thing here, shortest distance. In case I use move absolute, I'll hit next. Some status message, I'm good the way it is, hit finish. So the axis configuration has been completed. Our next step now is to try to send it as we are done configuring the system. Let me try to go to operation mode. Operation mode is also called BB. So I'll hit BB here. You see that there's a transition going on right now. So P3, P4, BB. These buttons are actually also available here under control mode. So you could click on here as well. So the controller is happy. The drive is apparently properly configured. So we have now 2 axes. One real axis, one virtual axis. If I double click on this MLC global var, we should see that those 2 axes, axis 1 and also the axis 1, have been added automatically to the controller. So the controller knows about it, and we will be using this name as a reference, so we can send commands and collect information about these axes in a very easy and straightforward way. Alright, so let me close this one. And before we continue, I would like to bring to your attention this library manager. And there are of course several libraries available, and there are more that you can add by coming to add library. But the one I would like to talk about is this PLC Open Lib. And this library actually brings all the important function blocks that we'll use for motion commands, such as MC power, that will help us to enable the drive or to apply torque to the motor. In other words, move velocity, so we can send a velocity command to the drive or to the virtual axis, stop command, reset air, what else? Move absolute. Of course, there are many options available, but the ones we'll use on this training will be basically MC power, MC move absolute, MC move velocity, MC stop, and we'll finish with MC gear in. Alright, just for your information. So I will close. We no longer need it. Let me collapse this library as well, so it will give us some additional room. And I'm using for this one, it's being configured as a ladder system. So I could use like a ladder diagram to move forward with this presentation. However, I would like to make it a little bit more visual. So you don't need to make this change. I just would like to do it so it will become easier to show some features without the need of adding, you know, coils and contacts and things like that. So what I will do, I will copy this name, copy, and then I will delete this letter POU. I will click here, delete. I will come to application, add new POU. I will paste the name that I just copied, so we'll keep the same name. It's a program, and it will be a function block diagram. So this is just a little bit different language, but the way we use it is very similar. If you prefer to use letter or even structured text, just go for it, no problem. All right. So I will double click here. We have one rung, and let me collapse this a little bit, and I will right click and I will insert box. All right, so insert box, I will come and search for PLC open, and then motion, and then I'll search for MC move velocity, which is here. Alright, so we have a velocity function block here. Now we need to instantiate or give this function block a name, and I will call it v-axis1 FB for function block move velocity. It's important to mention that the name doesn't matter. You can type anything you want or anything you are comfortable with. All right, so just hit enter, and you should see this auto declare wizard showing up. What we'll do, it will create this variable to us and send it to this declaration area here on the top. So I'll hit enter. So as you can see, the name that I gave to the function block and the type of the function block that I'm using. And now we'll move forward and give some parameters to the function block. And if I hover over the execute, you can probably see that it's a type boolean on the right side. So I will click here, and let's start by giving a name to this variable. It's going to be v-axis1 b for boolean execute or exec move velocity. All right. And again, the same process, I'll just hit OK. So if we hover over the velocity input, we'll see on the right side of the information box, it says real. So the type of the variable is real. I'll call it v-axis1 real velocity command. Again, the name doesn't matter. All right. Besides giving the name and the type of this variable, I will give it an initialization value. Let's say 50. So this will be a 50 RPM command to this function block here. All right. I'll hit OK. One thing that is important to mention is that the number, the value that I give here has the unit that we configured under the axis configuration. So if it's a rotary configuration, it will probably be RPM. For acceleration and deceleration, it will probably be radians per second square. And if it's linear, it can be millimeters per minute, millimeters per second on the velocity. Acceleration, the same thing, millimeters or inches per second or per minute square. So whatever you select under the axis configuration. I don't want to create variables to acceleration. I could, but I'll just give it like a hard-coded number. Maybe 500 should be good. Same for acceleration. And the axis will give, if you remember that I showed you those names, axis 1 and virtual axis 1, that's what we use for the reference. So this function block knows that it needs to send a command to this or this axis specifically. And we are configuring our virtual v-axis 1. Hit enter. So what I'll do next, I will delete these question marks, and I can come to this build area and build my code or compile as well. So we see we have no errors. Let me fix this so we'll be able to see it all the time. So we should be able to send a command to our virtual axis now. In order to see what's happening, I will come to the virtual, I will right click on it, I will go to diagnostic status. So we should see this new screen showing up. I will right click on this tab and say new vertical tab group. All right. So as you can see, we have a list of feedback here and also some details. In this case, axis is in stop mode. There is no position changing or no velocity changing. All right. However, once I download this PLC code to the motion controller and send a command, we should see some things changing on the right side here. How we do that? We come to the application, right click on it. There's this logging option, so we click on it. It will copy the, so let's just say yes, we do want to download the this PLC code to the controller. And it generates like a compiled version or a binary version of this code and sent to the controller. You see that it says stop and is also red. You can also see it in the bottom right side here. And we need it to be green and saying run. So let's come here and say start. All right, so our code is running. And you see it's green on the bottom right as well. And then if I double click on this execute input and come to this debug and write values, once I click on these write values, this value here will be taken by the function block. Just notice that we also have like a command or a shortcut, which is Ctrl F7, and that's what I'll be using moving forward, all right? Just to make it faster. So write values, so we see the value has changed to true here, and the virtual axis is moving actually. You see the position is changing, the velocity is 50, all right? So it's like a feedback, a fake velocity feedback. It's a calculated, another fake. It's a calculated velocity feedback, but there is no physical axis moving, so nothing that we can see it on the physical world. All right. All right. So what if I want to stop this now? Maybe I come here and say, all right, false, and then I'll hit Ctrl F7. We see that this input is false, but the function block is still active, right? And if we look to the feedback, it's still moving, so something is apparently not correct here. So what we need to do is actually this execute button or input means that the function block will take all the values from the input on the rising edge of this input. However, it completely ignores the falling edge. So that's why it has not stopped. So what I will do, I will log out. I will right click here and say insert network below. Right click, insert box, and then I'll search for MC stop. Okay. Let's start over. It's gonna be V axis 1 function block stop. All right, and it's gonna be V axis 1 B execute stop. All right, and deceleration again, I'll just hard code it to 500. Of course, for your machine you may need to change it or even need like a different number, so this is just for this demonstration. And again, I need to give it the axis reference, So it's going to be V axis 1, enter, and we need to delete those question marks. Alright, we'll come here and build. No errors. Come here, right click on application, login, and let's say we log in with online change, which means this motion won't be interrupted. So we'll just keep it the way it is and add an additional feature to it. Hit OK. So if everything goes right, we should still see it running. The virtual axis is still moving. The MC move velocity is still active until I come here and hit Ctrl F7, and now you see the stop command is done. The MC move velocity is false, and it's no longer active, and the motion has stopped, as you can see on the right side here. So let me disable this one, Ctrl F7, and let's make some real axis motion now. So I will go again, log out, and I will right click, say insert network below. I will search for a box, a new one, insert box, but now as I have a new, I will control a new axis, which is a real axis. Besides sending a motion command, before I need to send torque to the motor. So the motor should be engaged before the axis is able to accept any motion command. So what we need to do is to call this MC power, alright, and it's gonna be called axis 1. It's no longer V axis, it's axis 1, but again, it's just the name that I want to give. It doesn't matter, you can give it any name that you feel comfortable with. So I'm calling it axis 1 FB power, and it's going to be variable. Just hit OK, no changes necessary. As you can see, it has been added here, so we have it up there. On my enable, axis 1B for Boolean enable, and I'll hit enter. I'll hit enter again, so it's been created, and the axis now has changed, right? So it's going to be axis 1 now, no longer V axis 1, so it's the physical axis. I will clear the question marks. You may have noticed something different here. You see this function block has an execute input, this function block has an execute, but this one has an enable input. And enable means that this function block is sensitive to both edges. So when I enable or set this variable to true, the drive will be enabled. Once I set this variable to false, the drive will be disabled. Alright, so it behaves a little differently. Again, I will come to this login, and I will do login with online change. So the system is still running, and we probably would like to see what will happen with the real axis once we engage it, right? So what I'll do, I'll click on the second column area, so I highlight it, and then I'll come here, right click, and say diagnostic status. So now we have a status for both the virtual and for the physical axis. So on the physical axis, as you can see, axis is stopped, and it says axis in BB and AB, meaning that there are no errors. The bus of the drive is ready to power on, but it has no torque. So as you can see, this in operation with torque is not still green. So once I come here to this function block and enable this input, so Ctrl F7, so my physical axis now has torque. You see it's green. Once I come back here and hit Ctrl F7 again, it goes to false, the status goes to false, and the axis has no power anymore. Alright, next step, right click, log out. Now I will add some, let me collapse this to give us some more room. And I will add 2 networks now. So 2 networks. Once I enable my FB, my physical axis, I probably want to send like a motion command, and that could be a velocity command as we did for the virtual, but instead I'll do like a position command, right? So I will insert box and I will search for move absolute, which is this one here, right? And then I'll hit OK. I will call this axis 1 FB move absolute. Alright, hit enter. I'll do axis 1 boolean execute move absolute. Enter, enter, and then I'll hit, this is, if I hover over here, you see that the information box says it's a real type, so I'll call it axis 1 real position command, and hit enter. So there's a velocity command that I can create, but instead of giving a variable, I will hard code it again. So I'll call it 100 RPM for this velocity and 500 RPM for the acceleration and deceleration. And again, this is axis 1. So I can delete the question marks. Alright, again, application, login with online change, OK. I will, again, it has no power, no torque on the bottom right side here. So I will enable the physical axis, Ctrl F7, so the drive is enabled with torque. I will, do you see the physical axis right now is positioned at 349, so it's physically on position 349, and you see that the position command is 0. So once I execute this function block, you should see the drive moving to position 0. So I'll hit Ctrl F7 again, and you see that it has been completed, 0. Alright, let's send another motion command. What about 180? So 180, and I need to disable the function block again. A reminder, again, this is an execute input, which means that it's sensitive to a rising edge only. So it doesn't matter, whatever I do on the false edge, it doesn't take anything. So Ctrl F7, my position command is 180, and once I set this to true, you should see the position changing here. If you keep an eye on that, I'll hit Ctrl F7 right now, and the axis moves to 170. There's one thing happening, that's it's too fast, so we actually can't really see it moving. So here's what I'm gonna do. Let me log out. And that's the problem of hard coding some variables, is that you don't have the chance to really change it on the fly, but that's okay for now. So I'll set it to 10 instead of 100. Again, login. And okay. So my axis is sitting at 180. I'll send a command, let's say 345, and then I'll set it to false, Control F7. And once I change this to true, you should see this number changing, the position changing now slowly, hopefully, to 345. And I'll do it Control F7 right now. So you see the axis moving now. We can actually see it happening, right? Alright, so we have a virtual axis being able to move and being able to stop. We have a physical axis being able to move, which is an absolute position command. And we are also able to do to enable and disable, which means apply and remove torque from the motor. Let's do something cooler now. We'll do a synchronization process. So I will make the physical axis follow the virtual axis. All right. Before we do that, let me disable the axis first. So Control F7. Another thing I want to do is to come to this tab, right click, and do a new horizontal tab group so we can see both at the same time. So we have the virtual on top, the physical axis in the bottom. I will log out. And what I want to do now is to come to the last row that I added previously, and I will insert box, and I'll search for MC gear in. Alright, so I'll call this axis 1 function block gear in, and hit enter, and it's going to be axis 1 boolean execute gear in. All right, so what I want to do, we could do like, it's like a gear box in between the slave and the master. So what I want to do is, for every one rotation of the master, I want to do 2 rotations of the slave, and the slave is my physical IndraDrive axis. All right, so it's going to be 2 to 1. And I have no fine adjustment, so we can do 0. And the master is going to be my virtual axis 1. The slave will be axis 1. I will again delete question marks, otherwise the compile code will generate an error when we try to log in. I can kind of bring the message here. Let me come messages. We'll fix it a little bit, and I'll come to build, and no errors, so we are good. All right, right click on application again, login. Login with online change is good enough. So my system should be still running. And first of all, I will do, let me go to the virtual. So my virtual function block is set to 50 RPM. So I will double click here and set it to true, Control F7. So my virtual axis is moving, as you can see here. And the next step, let's enable the physical axis and double click here, Ctrl F7. My physical axis has torque, as you can see in the bottom right here, but it's still not moving. As you can see, the velocity is set to 0, all right? And I will do a gear in. So once I execute this function block, the physical axis should start following the virtual axis in 2 rotations per 1 rotation of the virtual axis. So Ctrl F7. If everything is all right, we should see my actual position of the physical axis is changing. The velocity is about 100, which is the double of the virtual. And yeah, I think we get everything going. That was actually pretty quick, right? So, well, let's do something nice now. We see numbers changing here, but that would probably be nice to see some graphic going on. So let me right click and go to Add Trace. You can give it a name, but Trace is good. So finish, double click on Trace, and you will see this blank screen. You can come to Configuration. So once it comes, we need to select a task. So the task we are using is the PLC task. So you can just select that and hit OK. And then you come here to add variable. So in order to check position feedback, there is like a structure available in the controller called axis data. So as I type axis data, it's like an array, and this array takes the name of the axis that you want to access, which is axis 1, and then you hit point axis number for the position, and then close square brackets and hit point again, and R actual position. So this will give us the real-time position feedback of the physical axis. And then I'll come here, add another variable, and we'll do the exactly same thing for the virtual. Axis data, open square brackets, v-axis 1, point axis number, close square brackets, point real actual position, and we are done. Hit OK. You should see that we have the 2 feedback position commands here. So I can come to the graphic area, right click, download trace, and you see like it's kind of moving, right? So if I hit Ctrl and scroll the mouse, you can see it collapsing on the vertical. If you hit Shift, it will scroll on the horizontal. So it's kind of moving fast, so it's difficult for us to see it. So I'll just hold it, and it's no longer moving real time anymore. So what I wanted to show you is like it's not synchronized in position, just in velocity, but as you can see, for every turn, so that goes from 0 to, let me try to expand it a little bit. So as you can see, it goes from 0, the bottom, all the way to 360 here. And while the green one does, which is the virtual, does 1 cycle, the blue one will actually do twice. And that's because we configured this gear ratio for the real axis doing 2 rotations per 1 rotation of the virtual. That's it. It's a pretty quick and easy motion system. Of course, there are many more advanced features. You could do camming motion, which is much more advanced, and you could do many more different motion profiles. I just wanted to make it like quick and easy so you can understand what it takes. to configure like a basic motion system by using Bosch Rexroth MLC. Of course, that would be a great idea to make a full backup of it once you complete this procedure, so you can have like a safe set for your project. And for that, there is another video that I created recently. I'll leave the link in the description below. If you like the video, please share it with your colleagues, and please subscribe to this channel if you want to see future videos. And well, thanks for your patience, and I hope I'll see you next time, and bye bye. Thank you.